delve off into writing the correct formula for a compound given its name. All right. If you have not already watched the second part of the video 3C, which talked about naming compounds and writing formulas, you might want to do that first. That goes through all of the steps. We're going to quickly talk to each of those steps as we look at this series of probably about 3 videos. The first one we're going to use here is non-metal plus an anion. The next one in this series will be a group 1, 2, or 3 metal plus an anion, and the last one obviously will be our transition metals and our other 5, 10, antimony, lead, and bismuth, and how we write those. So, if you need a more detailed explanation, if you haven't heard it in class or from reading your course support materials or any of the other handouts you've received in your blackboard here, you might want to relook at that before you get started here. So, let's look at this. We're confronted with the problem of writing the correct formula for a nonmetal and an anion, given that name. These should be, I think, the easiest because there are only really 2 steps we've got to do. We've got to look at the name. We've got to write the symbols for the nonmetal and the anion, and then we're going to take any Greek prefixes attached to those elemental or anion names and convert them to numbers, which we're going to use as subscripts. So let's look at this first one. Here's our example. We have the name tetraarsenic hexaoxide. All right, so arsenic, I would go ahead and just write AS, find it in the periodic table and write it down. And oxide, you have your anion sheet with all of your anions on it, so we're going to write a big O for that one. Hopefully you know the Greek prefixes or you are learning them. Maybe you'll be lucky enough to have them on a sheet for any exam or quiz that you've got to do, but it never hurts to know them. Tetra is Greek for 4, and hexa is Greek for 6. So as we say up here, we're going to take those Greek prefixes and essentially make them the subscripts on each of our symbols. So the correct formula we would write would be AS4O6. All right? Not a really hard thing to do here. So I think we probably just need to practice a few. I know that you've got a lot to practice on the worksheet that corresponds to this lesson, and then in most classes there is kind of a little quiz or a homework assignment requiring you to do some of these for a grade. So let's make sure we do well on that. All right, let's look at our examples or practice here. All right. Nitrogen trichloride, dicarbon hexafluoride, tribromine pentaoxide, and tetrasulfur heptaiodide. All right? You might want to, as I said in all these previous ones, go ahead and put this thing on pause, write out your answers, and then when you come back from pause, you'll be ready to pull up the last slide in which I've already put the answers. And we're going to compare your answers against the correct answers. And if you've got them, you're done, and you ought to go on and spend your time doing other important things, like learning how to do it, how to write formulas for group 1, 2, and 3 metals and anions, and especially transition metals and anions. But in any event, we'll quickly walk through each of those to make sure you understand why we came up with the name we did. So put this on pause, write your formulas out, and then we'll see what we get. All right, here are my answers. Nitrogen trichloride, NCl3. Dicarbon hexafluoride, C2F6. Tribromine pentaoxide, Br3O5. And tetrasulfur heptaiodide is S4I7. Now I want to make one little disclaimer here. I don't know whether all of these exist. I've sort of made up these names just to get some points across today. So you can kind of look at that and hopefully come up with the right answers. All right, so let's just kind of look at the first one. Nitrogen, so we wrote N, chloride, so I wrote Cl. There was no prefix in front of nitrogen. The fact that there's no prefix doesn't mean there's none there. As soon as I write the element name, I know there's at least one atom of that there. So the absence of a prefix means one of those. All right? And no good chemist ever puts a 1 in there. So don't write something like N1Cl3. NCl3 is the correct way to write that. And the 3 obviously came from the Greek prefix tri. All right, the next one was dicarbon hexafluoride. So carbon, found the C, we already knew that. Fluoride, most of us know now that that's F. Now some of you insist on abbreviating fluoride as FL. I'm not sure where that comes from, but I always mark it wrong when I see it. All right, fluoride is F. All right, di, Greek prefix for 2. Hexa, Greek prefix for 6. Just make those numbers the subscripts on your formula, C2F6. All right, tribromine pentaoxide. Tribromine, now remember, the first element always takes its real name. No change in endings or anything like that. So we wrote Br. All right, tri, Greek for 3, so we know that's going to be the subscript on bromine. Oxide, our anion sheet tells us what? That's O. And penta is Greek for 5, so that's our subscript on the O. Br3O5. And then tetrasulfur hexaiodide. Sulfur, spelled correctly, not S-U-L-F-E-R. All right. Sulfur, tetra, Greek for 4, so we know that that's going to be our subscript there. Iodide on your anion sheet, just a big I. Hepta, this is one we're not used to using a lot. That's 7, so that's our subscript on iodine or iodide. So S4I7. Hopefully you had no problems getting these right. If you missed one, hopefully this sort of brief explanation is going to help you understand how we did that. So now it's time to go to your worksheet and practice writing these. You know that one way or the other, either in your course support material in Chem 104 or in your postings in Blackboard, the answers to those worksheets are already there. So don't look at those first. Do these, then go to the answer sheet and see how well you've done. So that's going to end this one, and we'll get on to the next one here in just a minute.